Alright, time for another DraftScience video presentation. Alright, so this Meskimos person is putting up another big giant comment. I'm not going to read all of it because it's all kind of mushy. And it sort of just gets to this argument. Okay, I would argue that I have provided you, a reasonable person, more than enough evidence to doubt relativity. Whatever, woo space, bent space, time. To doubt, certainly the kinetic energy formula, complete pile of crap. I mean, no good evidence supporting it at all. Completely violates all of Newton's laws. It's not Newton's mechanics. Just a big fraud. A conspiracy by religious people to turn physics into a religion, pretty much. And then this whole subject of photons and quantum mechanics and all of this wooey bullshit about entanglement and superpositions and forces, interfering with forces, kind of nonsense. So the argument would be, I would say that for a rational person looking at this as a trial, the idea would be, your assumption would be, physics should be physical. That it should obey mechanical laws, not woo laws, and pixie law shouldn't be in place, and that should be your assumption. Just like presuming somebody innocent, until proven guilty. So you shouldn't believe in woo until the woo is proven. You should be like anti-woo. It shouldn't just be because it sounds like a good story. Okay, Jesus walking on water and all this other stuff. You don't believe any of that crap because, without any evidence, it just sounds like a story. And without any good evidence, this all just sounds like stories, right? And we know their evidence is terrible. That, Feynman couldn't describe the actual two-slit experiment to save his life. He didn't know what the actual pattern looked like. He thought there was detector experiments. He doesn't know that, when you're shooting these things this great distance, they don't separate, and so they don't create two humps in in different points in space. That the two patterns of the two slits would be right on top of each other. I mean, all these little details completely annihilated. And then I bring up like Eddington experiment never being repeated. Can you believe it? 400 times better resolution from space, and you don't need an eclipse, and they've never tried it. You believe that NASA no NASA engineer ever even tried? And let's understand, the guy who died this year, what was his name? I always forget his name. Sorry, dead guy. Worked for NASA for 30 years doing laser experiments, and points out that we never saw any bending of light outside the lamb of the sun, the corona, one radius out. No bending. So outside the part where there's a bunch of particles, no bending. A bunch of stuff for the light to reflect off of, so to speak, diffract. So just ignore all of that. And so, the real argument here is that you have the opposite point of view. You're assuming guilt, and I have to prove innocence. You're assuming woo, and I have to prove the woo isn't the truth. I have to prove Jesus didn't walk on water, and I have to prove all this stuff didn't happen. That's really irritating, frankly, because your mindset should be the opposite. You really should be going into this saying the extraordinary claims should need the extraordinary evidence, okay, and the ordinary claims should just need ordinary evidence. I'm making the ordinary claims. They're making the extraordinary claims. And you somehow inverted this standard of proof. But anyway, that's the way things are, so I'll just have to endeavor to persevere. I just have to keep rowing the boat through the bullshit. So anyway, so this is sort of I suppose, supposed to be a complimentary, in a way, comment, but it really isn't, because he's comparing what I'm arguing to absolute crap. And so no, my argument isn't their crappy argument, okay? It's a completely different argument that's clean of being full of crap, full of stupid assumptions and trying to force interference to be a real thing. It's not a real thing. Forces don't interact with forces. I'm just, the two laser beams are screaming it at you. You can't make them bang into each other. Gravity doesn't hit gravity. Okay, it has to hit another material object. Charges don't, the forces coming off the objects don't bang into each other. The force has to go to the other object to make something happen. The force has to hit matter. Nothing happens in the universe because a force interacted with a force. It happens because a force interacts with a piece of matter. You should be able to understand that must be the truth here. There's just so much evidence indicating that really must be the truth. But you won't accept that axiom. Your assumption is that no, whatever the forces are, they're in some kind of medium that forces them to infect each other. Anyway, so it starts off a little bit flawed because he says positron. I don't think he meant to say positron. I think he meant to say proton. Yep, that proton transfer, I'm going to put proton there, transfer positively charged part I wanted to bring up too. So it was the part in the video where he's trying to say, well, now that it's positively charged, let's knock the extra protons off. And there really aren't extra protons. There's just an absence of electrons. Anyway, it was again a nice example of how religious-like agenda. Quantum Pody brought up at the end of the Action Lab video. Yeah, well, the whole thing, that last 2 minutes of just complete religious dogmatic crapola was, it's ridiculous that they repeat this shit that they haven't got any evidence for, as if it's the most proven theory in the history of mankind. Huh? I mean, this comes out of Feynman's mouth, right? The most proven theory, and yet he's the guy who can't, like I said, can't come even close to accurately describing the two-slit pattern, or the distinction between the pattern in electrons and the pattern in photons. He just calls them the same experiment. It doesn't matter whether we're talking about an electron or a proton or a zigaton or a fuckaton. It doesn't matter what it is. It all does exactly the same thing. And they don't do exactly the same thing. So again, it's just such a... if you can't just see how unscientific that is, and just, and they talk with such reverence about their science and how, you need to be careful and you need to not assume and you need to do all this stuff, but they just fall into the same exact traps they're preaching against. It's okay for their religion to be full of bullshit, but nobody else's religion can be. It's just, hypocrisy. All right, or at least the bridge between the first part of the video and the real-world experiment and the quantum rhetoric was thin and rather minuscule. Yeah, well, there was really no need to add that crap, and it didn't do anything to make it more understandable about what you're actually doing. So the idea of knocking electrons with energy makes sense. The idea that frequency would have something to do with it, he should have made that argument more obvious in terms of there's a resonant limitation of the thing you're blowing on. And so if you blow at a certain frequency, you'll blow the bridge over. You blow at the wrong frequency, you won't blow the bridge over. I mean, that kind of analogy would have been a better one. I have stated that I find out more and more research articles that point to the same conjectures that DraftScience guy has shown here. So that's just wrong. Okay, none of these things you're referencing have really anything to do with recovering a particle rational mechanical model. They have to do with just converting. Again, they're trying to force forces to interact, and they can't. So their model can't work because it's still relying on some wooey notion that a force interacts with a force. That somehow you can, by putting photons through slits, I turn them into some other kind of force, and now they're special lasers, and now the laser beams will bang into each other. That's all you're saying. You're saying I shoot lasers through a slit, Therefore, the laser turns into some other kind of light, and this new kind of light does interfere. I can bang it into the other beam somehow. It's that literal. That's all you're saying. I mean, it's all they're saying. It's trying to reconstruct some idea of a, that somehow you're interfering, that the light is interfering, when, as I've argued, it has nothing to do with light interfering. It has everything to do with light being fragile and breakable, and then you can put the pieces of it back together again. Light's a glass. You throw it through the thing. You smash it. You take the pieces and you can make glasses again out of the pieces. I mean, it's that kind of thing. Anyway, because the pattern is so simple, it's just an on-off, just a frequency. You can put the frequency back together. All right. Let's see. Our results. So these. Well, I guess as stated, I find it more and more research articles. Blah blah blah. Okay. I think the articles are interesting as they also provide Schrodinger's equation counterparts to the interference pattern. They're really not counterparts, so I guess and if you're saying you understand the Schrodinger equation in any kind of like image sense, the equation is basically saying if you know everything about something, then you can know everything about what it's going to do. Well, great. Who knows everything about anything? Oh, that's right, nobody. So what? I don't even understand why this Schrodinger equation is at all significant as an equation, because it doesn't have definable elements in it. The elements have to remain ambiguous equations. The elements can't be solved. So if you can't solve the variables in the equation, what's the point of the equation? So it's just transferring, again, their notion of spin or their notion of different properties and saying, well, if I have knowledge of these different properties, okay, then I can extend that into a future condition. Well, duh. We already know that's cause and effect. So what do I need that crap for? I'm just saying I don't think anything's solved with Schrodinger's equation. I think that's just more of their talk. We have a special magical box that does something. I've never seen the box actually do it. They just keep telling me about the magic trick they did, and they never show me them pulling the rabbit out of the hat. All right, pulling it out of my hat anyway. If I have a hat and I say, well, pull a rabbit out of it, they can't pull the rabbit out, right? They can only pull the rabbit out when the hat is their hat on their special little table and in their special little laboratory. That's when they can pull the rabbit out, but they can't do it if I provide the hat. All right. So this is a quote from the paper. Our results using quantum potential show that one can, in fact, remove the ambiguity of whether quantum objects are waves or particles and provide instead a clear, intuitive understanding of quantum interference in terms of well-defined particle trajectories. So again, they're just saying that we can turn it into particles and have particles bang into particles. So this is the Bohm bullshit. This is the other crap interpretation that again doesn't describe the right pattern. So again, it's just so lame. Now, if one of these articles had a picture of the actual, the actual slit experiment, the article that would be interesting is one that actually does this, that we know it looks like this. I better draw it better than that. All right, so we have these nodes of the same size. We know they're going to be the same size, and we know that the double slit pattern is this thing, okay? I mean, I didn't draw it very perfectly because I only have 3 and 3 and 3, and this one is double. Okay, so right away we're already in trouble. Just pretend there's 6 there, okay? Anyway, so we know we have a pattern. It has distinct features, all right? This crap won't create that pattern. So is it really the double slit pattern? And if we're going to play this game where we're going to say, okay, let's make a double slit, except we'll make the slit so tiny, okay, that the difference between this distance and this distance will be so irrelevant that it can't possibly change what the pattern's going to look like, right? I mean, the two distances will be annihilated. You're essentially just saying it's just this. It's a single impediment experiment because I'm just going to make I'm going to make this irrelevant because the distance will be so tiny. I mean, does that make any sense? Of course it doesn't make any sense. So why do you keep defending these conditions? That's part of their magic hat trick. Okay, that's a condition they create to make the trick happen. The trick can't happen if they do the real world thing, you know, where they take a normal size slit and a normal size impediment and do the experiment. Then all of a sudden all that crap turns to crap, because again, this wave math doesn't work. This crap will not get you the right answer, okay? It doesn't get the right positions for anything. Two waves fails. All right, and as I pointed out, the math that works is this math. The math that concedes there's 4 point sources at the surfaces, that the surface is the experiment. That's the cause of the effect, okay? It's not some mystery between photons and all this other crap. No, it's that simple. These surfaces cause some photons to make this pattern out here. All the light that goes out into the fringes is coming from these sources. It's not coming from here or from here. So show me that drawing. Show me the drawing where they have nice clean lines that say, well, look, as I've shown. Okay, the simple drawing that simply indicates that all you're really saying in these slit experiments, this is the impediment, this is the slit, is that you have 4 vectors, 1, 2, 3, 4, and those 4 vectors at the right distances will be in phase with each other. They'll be in alignment. The photons will all be the same period. Now what they can be is like this, you know, one of them could have started early and one of them could have started later. And the point is that you put those photons into the experiment, and what you'll take out of those pieces is you'll remake 2 photons. So you'll take the pieces of 4 photons and you'll make 2 photons out. So half the light that goes through you'll get back again. Some percentage. Maybe it's not half, maybe it's 40%. But anyway, something like that. But show me that drawing. And then tell me they already figured it out and there's already people doing the right thing. They're not doing the right thing. So they're still trying to make this wooey interference crap happen here. Like all the photons are doing something in here. They're not doing anything there. They did something here. They did something here. They did something here. They did something here. They got broken, and all you did was fix them. All you did was give them the opportunity to reestablish a very simple pattern of frequency. So anyway, this page was just garbage. It mentions, you know, look, all of these pages mention all kinds of, I mean, I should read them just because they're so full of bullshit. They mention detector experiments. They go through the same Feynman crapola. I mean, this one's from 1979, and it has the same bullshit assumptions. And again, it's not even dealing with the real pattern, with the real envelope. It's, look at these images, aren't anything like the double slit experiment. Come on. You know, why is this reason to have hope that they're getting to the right answer? Because they're really not. You know, and then this is more about, again, particles, but again, it's the slits with an finite width, right? That is 2 times the wavelength, the de Broglie wavelength. Oh, pathetic. So this is again electron experiment, you know. So just look at this one's just covered in bullshit, and every image is a bullshit image. Look where they put the waves in the single slit. Oh yeah, that's right on the surfaces. Oh yeah. So again, they drew it really big to kind of give you an idea, but no, the waves are on the surfaces. But the double slit doesn't have 4 waves, it's only got 2. So when it transfers, let's see if it goes to the double slit. So there it goes to the double slit, and it's making, you know, the traditional mistake. 2 waves. 2 waves won't create the pattern. So no point in doing that. Let's see if it's 2 waves. What a pile of crap. So they have a single slit that has 2 waves, and yet they make a double slit and it doesn't have 4 waves. So, you know, what, you know, Two sources again here. It's all this traditional stuff that doesn't get right answers. Then it plays, it has the Feynman bullshit here, video. You know, quotes from Feynman, again, who couldn't describe any of it accurately. You know, they got the implication that there's two humps here, one hump over here, all the same mistakes over and over again. Two sources, doesn't create the right pattern. You know, so again, single slit, two waves, double slit, two waves. Does that make any sense? Of course it doesn't make any sense. You know, is that the double slit pattern? No. Yeah. So what do you want me to say? You know, it's junk. Whatever. So to say they're getting somewhere, they're not getting anywhere. Collapse of the wave function. This is all the same. This is just an article full of the same bullshit. You know, look, all of these videos that I've played and debunked and proven and shown that they're all crap. Okay, in terms of what they're describing and how they're describing it. They have all kinds of errors in them. Alright, again, the two waves. Veritasium's making two water waves. It doesn't get the right answers. Why are you doing that? Because it's not a parallel. It isn't the same pattern. Alright, anyway. So look, fine, okay. You haven't watched all my videos. You don't know that I've already been over this crap. Maybe that's part of it. I don't know. It just seems like you're just trying to say, bring up Wolfram, which is, way off in another, he's way gone in terms of, lost in it. So he's just saying about an animation. So this is the other part that's a little bit annoying. Or a simulator, or a calculator, right? That's what that other thing was. The thing Brosy linked to that was so horrible. Yeah, that's pretty easy to fix. I mean, you can get the programming code. It's all open source, right? So I was thinking I would fix it, but I mean, you have to go through it and find where they're doing the calculations and just redo them a different way. And so I already pointed out. So you're describing as if you couldn't do it. You can't understand how it would be done. And I've made it so clear how simple the math is that, of course, it could be done. I mean, it'd be easy. It's not even difficult. It's so simple. So again, let's just go through it real quick here. Just because the math, you don't need any integrals. You don't need a whole bunch of complex stuff. So all you're basically doing is saying, okay, there's four sources. So here's the double slit. And all you're saying is there's two distances, this distance and this distance. All right. And now you're just gonna make in a mathematical space this pattern, right? So we know that this line is the radius of the distance. So we know, so those are all traditional things in the math, except you're just adding another distance. You have D1 and D2, right? So that's all you need is D1, D2, this length, and the wavelength of the light. And we're done. That's all the input you need. So these are all really easy to ascertain variables. And so what the first thing you're going to do is just do this. You're just going to add this length to a line, okay? And the other line will be short that distance, okay? And that tells you, your 90 degrees, what you have. And then you're going to take, you're going to do your L times pi, and you're going to get the length of this line. So now you have the length of this line and you have the length of these lines, and now you're basically just going to take the pattern created by these lines and put it on this line. So you're basically just going to take these wavelengths that are in here and you're basically just going to put them on this line. So you're basically just saying, what's the length of this line? Okay, and this line in terms of frequencies, and then you're just going to put them on this line. So the first one you do is the narrow slit, and you find out, let's just say it's ideal 4, and 4 divides into 2 evenly, so I can put a big object here. So one goes here, and then How do I make 4 out of that? All right. So this has to be a half. Okay. So there's be a half here. Right. The center of an on. So a center of the on will be here. The center of the on will be here. Okay. And you'll have one here, and then you'll have one right in here. Okay. And here. So that's 3, and then the 2 halves add up to your 4. Right? 1, 2, 3, and then these 2 halves add up to 4. So, you know, that's it. So all you're doing is saying, I'm just going to take that, put it on there, and then I'm going to do it the same thing for this. So I don't know, you know, mathematically that's not a tricky thing to do, right? To just extend this distance as a parallel, right? I mean, whatever this number is, say it's 18, I do 18 to this distance, you know, as a proportion, D1, and then I just do the same proportions going to exist for this big distance, okay, which is whatever pi times L, right? And so it's going to be exactly the same proportion. So I just do that simple math, and it'll tell me the size of these nodes, and that'll tell me, you know, where they're going to be. This one will be the same size for now. Anyway, and then you do the same thing for this, and that's going to make your little nodes, right? On, off, on, off, on, off, on, off. And then all you need to know is which ones, you know, these aren't going to be visible because it's only going to, the only ones that are visible where they're both on. So wherever they're both on is where you'll see a visible dot, and that'll be it. So that's all it is. It's that simple. So yes, of course, that's easy to simulate, right? Now they do all this trajectory math with their sine thetas and all that stuff. I'm just saying you can do it without doing all that angular triangle stuff, because you can do it just by understanding this line is exactly proportional to this line, this distance, in the sense that the notches, the wavelengths, are going to be the constructive interference points are exactly the same number. So, and you know the things are the same size, so you're just basically saying how many, if there's 18 nodes, I just divide 18 into the length of this circumference, and I'll know exactly how big the nodes are, and as long as I know where they're starting, I can just do that division. So I'm just saying it's that simple. So of course it could be simulated. You don't need Wolfram, you know, you don't need some fancy mathematical device. This is really simple math. There's nothing, there won't be anything in here, no integrals, no anything complicated. Anyway, so I'm just pointing out it's really easy to simulate it, but frankly, you people should be smart enough that you don't need a simulator. Frankly, I mean, isn't that for people who can't understand it? You know, it's not really not for people who already, oh yeah, I can figure that out in my head. There's approximately 7. Okay, and 7 nodes. You know, it's not. They can make the simulator in their own head. They don't need somebody to do it for them. All right. Anyway, so this was more crapola. In the previous video, we had a conversation with Bill about the water and air waves, comparing photon waves to the double slit experiment, and is vague because air, we talk about air molecule pressure changes, blah blah. Well, of course they're not similar, and they don't create the same pattern. One's obviously distinct in the sense that one's an obvious medium, the other one has no obvious medium. One of them, you know, you can throw water at water and the water bangs into the water, right? If I throw a bucket of water at a bucket of water, I know the water molecules are going to hit each other. We know that light doesn't do that. I mean, the comparison shouldn't have been made in the first place. This isn't seems like, is like. It seems a little bit like, isn't anything like. Okay, because, you know, I've already, comparing ducks to platypuses isn't very smart. Okay, anyway. So, just bullshit. So I've already showed the pages are full of bullshit. Farmer, it says skip the farmer, but I have one more final link to share. I found this article when looking at The neutron gun, right? The very idea. So yeah, good luck finding how they shoot neutrons. Anyway, I didn't quite get there yet. Yeah, I don't think you're going to get anywhere. But it was interesting to see other people have considered, after all, that slits and the material of the electron gun experiments may contribute to the interference pattern. That slits and material. So, okay, so this is a reasonable argument that some people can make, that yes, of course, they recognize electrons are solid objects, and they're not going to split in two, and they're not going to interfere with themselves. So, yeah, come up with a rational reason why there's a pattern, and the rational reason is electrons are charged, and they're going to be influenced by the fields you're putting them through, and when you put them through two slits, you're putting them through a charged field. Alright, anyway. So, yeah, that might be reasonable. But I'm sure the way it was done is wrong and idiotic and stupid. So, again, it's probably more Bohmian bullshit. I think I already opened this, frankly, but we'll open it again. Yeah, it's the same as this one. So, yeah, if you read the full blah blah article, it's again just more attempting to defend. This one's a little different. Okay, never mind. Alright, so yeah, so the problem is that the electron, this is an insanely not correct description of the actual experiment, so it doesn't mean much. I mean, they have to put it through the Broglie wavelength of an electron is this insanely small distance, so they're putting the electron through an insanely small slit. Blah 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 blah. All right, so we didn't read this one yet, but I'm sure it's crap, and it's from probably 50 years ago. Let's see. What's the date? Oh, December 2012. Well, anyway, yeah, so I haven't read this yet, but I'm sure it's crap. But anyway, the point is it's on my side, but I'm sure it's still premised by crap, because they still don't understand what a photon is. They're still thinking a photon is one thing. It's an object, like an electron. It's moving through space as a ball. It's not what a photon is. Alright. So I'll just do this last paragraph part because it's on another subject that's, you know, the single photon crapola. You know, I have been over it a few million times, but we'll go over it some more, and I'll attempt to give you a better illustration of the argument. Okay. Alright, last but not least, the real question. I still find it problematic that if single photons, so again, the very notion of a single photon emitter would be what? Okay, a device that creates one photon at a time. So there realistically isn't any such device, and the only way they can do the experiment is to approximate what one photon at a time, by putting screens in front of a light source to try to block it, you know, and keep blocking and blocking and blocking and blocking until they just have a tiny bit of stuff gets through. But again, how do they know what a tiny bit is? It's like the door on the microwave oven with the little holes in it. Do you think none of the microwave energy is getting through the holes? I mean, what's your theory? That the microwaves actually are big blobs and they can't get through the holes? Or do you kind of understand that, no, there's a bunch of pieces of microwaves getting through the holes, but the pieces can't hurt me? The only thing that can hurt me are the whole microwave. So as long as I'm getting hit by pieces, I'm okay. It's when I get hit by the whole thing that I'm in trouble. Alright, anyway, I still find it problematic that if single photons, let them be composites of bits, are shot through the slits. Right, so if you could actually make a single photon and put it at the slits and collect a single photon at the other side. So you're just doing single photons. All right, so that's a photon. And that's all there is in the space is that. Well, obviously I'm saying the photon has a polarization, makes it a little more complicated. So that's the photon. It's flying this away. All these little bits parallel. Going into the two slits. Okay, what's going to happen? Well, it's going to get probably broken, right? And nothing will happen. Okay, you won't be able to do anything. That's right. There's no theory I can provide where you could ever get fringes, okay, pattern over here, all right, without having pieces of photons hitting here and pieces hitting here and pieces hitting here and pieces hitting here. So for the the single slit's easier because you only need pieces to hit the two slits. So obviously in that sense you could duplicate the single slit pattern a lot easier than the double slit. But the truth is you'd have to have pieces at both these surfaces to create these path length differences to recreate a photon. You can't recreate a photon because you can't, if you broke this one, if half the photon went into the surface and only 2 bits come out, well, obviously I can't reconstruct two bits, and obviously I can't, I can't send them these path length differences. I can only send them to very different locations. So there's no way I could ever send these 2 bits to the same place and have them hit and make a photon. And again, just 2 bits isn't enough. So the only light that could possibly get through as a single photon went right through the center, and he just made a blob here. But I certainly couldn't make any fringe pattern. So, but again, so yes, that's true. But the argument is that you just don't have any evidence that this condition is met. That you have any experiment that proves you met this condition. So it's like the microwave door. All right. Theoretically, I could make those holes a little bit smaller, and the truth is I can make it so no microwaves show up. I can sit there with a meter right outside the door and say there's no microwaves getting through the holes. Does that mean, in your opinion, that no energy from the microwaves is getting through the holes? And see, in my opinion, there's a ton of energy getting through the holes. It's just not reforming because you used circles. And circles diffracted the bits in all directions. You're not diffracting them with a rectangle where they only go this way or they go that way. You didn't keep them in one dimension. You flew them in all kinds of dimensions, in 2 dimensions. So you spread them by the inverse square law instead of just the R law. And so now you've made them a lot less dense in every area they hit, and therefore there's less and less likelihood that you can put the pieces back together because you're throwing pieces at more area, at a larger area. So I could make little changes, and then you would start to get microwaves back. So that's what's really we're having. You have some doubt that in the experiments that have been done that there is any real evidence that it's a single photon. So when they're putting those screens to darken the light, so you have your light bulb, all right, and you put a screen in to take away, to obscure the light. You put an opaque object in. Well, what does the opaque mean? It doesn't mean they put a piece of steel there, because then they know it's not going to work. So opaque means that it's got some little particles in it of obstructing material, so it's semi-transparent. And so the whole point is yeah, it's semi-transparent. So that's why they use usually more than one. It's because they have to finally get to the point where they've made the holes, okay, the right size, right? If they make big holes in the microwave, well, microwaves get through. They made them the right size where they're finally getting no photons. So they don't see any photons. Does that mean that no energy is getting through? That none of the pieces of the photon are getting through? Well, I would argue, of course not. Tons of the little bits of photon are getting through. They're just not getting through as whole photons because you've made the slits so narrow, right? If I make very narrow slits, what I'm guaranteeing is that anything that gets through isn't going to be in one piece, because the photon, the photon has a polarization size that's bigger, okay, than the slit it's going through. So obviously no photon that could be received as a photon, as an object, no whole photon could get through, but lots of pieces could get through. That you could logically understand. So you're breaking every single photon on this side, but that doesn't mean you don't have any energy on this side that can be made into photons. You have lots and lots of it. So I'm just saying it can look like it was completely dark. So I can put obscuring filters in front of a light bulb and I can look at it and say I don't see any light at all. My argument to you is there's a ton of pieces there, and all I have to do is diffract them and I can put them back together. But if I don't change their path, okay, because there's multiple tiny little round slits, you know, they're moving in all kinds of directions. So if I don't in some way alter their path, I can't make them back into a photon. That should be enough. Anyway, I still find it problematic that single photons, let them be composites of bits, are shot through the slits. They break into parts, so they are already parts. I'm just saying the single photon, you're basically saying the only way to make single photons, you can't turn the light down and have one photon pop out of the light bulb. We don't have that device. So until you make that device, you're having to rely on obscuring the light. And how are you obscuring it? You're obscuring it by putting, frankly, doing this to it. Putting a bunch of little holes in the microwave door. And you certainly haven't guaranteed that no energy is getting through the door. Alright, they break into parts and land on the screen. The second photon is launched after the first one hit the detection screen. So obviously I would argue that would be impossible. What you can do, right, what is completely possible, is to have photons that are in phase but in different time. They're produced by in phase but at different times. So you have one photon in space here and you have another photon in space here. And any overlap between those photons could obviously create another photon, right? So they don't even have to overlap, because I could have this photon, this piece, this element, and this element show up at the screen, right? These two happen to go to the right location. This one goes to the right location, and then this one goes to that location. Their timing is still good. They're still in phase, so they'll make a photon. And obviously I could have them both go into this thing at the same time. I can just change, you know, this one got killed, so I just replace, and this one got killed on this one, so I just replace this one with this one, and I'm back in business. I have a photon again. Alright, they break into parts and land on the screen. The second photon is launched after the first one. Okay, so I would agree that if you can create that experiment with any kind of reliability, alright, where you actually know the elements of a photon are not in the box, there's no elements, there's no pieces, and you're just going to send single photons at the two slits, okay, whole photons, I would agree. If you can produce that experiment, I'll be convinced. But clearly you haven't produced the experiment. Clearly we don't have anything close to anything that really establishes the truth that only a single photon is in an experiment. And clearly the Veritasium video is a good example, in the sense that he clearly had to increase the sensitivity of the photomultiplier, and by doing that he created so many error photons that he had to decrease the amount of time he does the experiment in. He can't just let it run for a day, because he has made it he's made his photomultiplier so noisy. So it wasn't until he sped the experiment up and essentially guaranteed more photons were in the experiment that he, at a time, that he created some pattern. And it was a pretty lame pattern, by the way. So, I mean, that's a pretty good example of in my opinion, that it doesn't work. That it really doesn't work. That when you really guarantee there's only one photon in the experiment, it doesn't work. Anyway, I kind of understand it if there are billions of broken photons scattered from the slit edges. So first you have to say, if there are billions of broken photons being created by the semi-transparent opaquency you've put in the way, right? What is the opaque, the smoked glass? What is the smoked glass? Oh, that's already a bunch of little slits, okay? That's a bunch of dirty, particles that are completely opaque, that will not allow the energy to transmit, okay? And openings where it can transmit. And all you're doing is saying, look, there's some pieces that survived the gauntlet and got through. So I'm already creating an obstacle to break the photon. So it's already broken photons that I'm sending towards the slits. There's no whole photons in the game anymore. All right. It would make, all right, if there are billions of broken photons scattered from the slit edges, it would make statistical sense that part of them will combine to the correct phase. So whether it's billions or millions or thousands, the argument is that there's only really two choices if your light started in phase. There really is only two choices. You're either getting in phase, you're moving towards being in phase, like a good solid frequency, everybody being the same period, or you're moving away from that condition. And we know that based on just the fact that the light nodes are bigger than the dark nodes, that the fudge factor allows you to fudge quite a bit on the positive side of making a photon. So the photon doesn't have to be explicitly constructive interference. It doesn't have to be exactly, okay, the exact perfect wavelength to be recorded as a visible photon. So you're really just saying you have a 50-50 chance of putting a photon back in phase. It's either going to be in phase or out of phase, and there's really just a 50-50 chance that the distance will make it in going in phase or going out of phase. It's not like it's more likely to be out of phase. There's no reason to think out of phase is more likely. But if you shoot them so distant in time, how will the recollection step would work? Okay, so again, I'm saying they can't be so distant in time in that there's more than a wavelength of distance between two photons. If there's more than a wavelength of distance between two photons, they can't interfere and create a new photon. Not interfere. They can't break, and you can't make a new photon out of the pieces because you'll have too big a gap of silence, of no bit. So yes, you can't make this stuff go faster, you can't make the stuff go longer, you can just make the path lengths different. And you won't be able to make a photon out of something that is too many path lengths different. If a photon is just 5 wavelengths, let's just say, 5 bits, you can't have more than, like, say, 2 bits of distance between two photons and be able to fill in those gaps with distance. Whatever the right way to say that is. You're correct. So if you can show me the experiment that's done where you've demonstrated that there isn't a bunch of pieces of photons flying through the experiment, if you can show me where they're not using a slicer, a dicer, okay, to create the illusion of no light, okay, and that's all I'm saying it is. Like I said, the microwave is saying it right to you, right? The microwave door is saying to you, I know those bits of energy are getting out of that box. I know some of them have to be getting out of that box. There's holes. I know that the stuff's got to be coming through those holes. But I know what I know is that the stuff is now mute. It's now harmless because it's broken stuff. So the only stuff getting out those holes is broken microwaves. They're not in a condition that can hurt me. And so I'm just saying, if I made this black box, this sealed box, and we made this light source, and we put this opaque, the smoked glass, I can theoretically know that even though it looks completely black in here, that it's probably not, because I'm just being fooled by the fact that the photons aren't in a form I can see. but the energy's still there. Part of the energy. Obviously, you've killed a lot of the energy because you banged the photons into truly opaque little bits inside the glass. Alright, anyway. Yeah, so that's probably enough. So the bottom line is like I said, as I pointed out in yesterday's video, okay, there's lots of experiments, lots of little details. What you should recognize is how unattentive to those details conventional physics is, and how broad-brushed everything they say is, how hyperbolic it is, how exaggerated it is, how they say it's the same as waves, it's the same as this. Feynman's even quoted as saying, all you have to do is do this two-slit phenomenon, and then everything else that happens, yeah, it's the same as this. When it's not the same. I mean, you know what I mean. I mean, light reflecting off water, all the other ways that you'll end up with a phenomenon. You know, the fact that as you change the thickness of a piece of glass, you change its reflective index. You know, and you get this. In a sense, you're creating the same kind of change, in that the fact is how much light will reflect off the surface changes, but it cycles. You know, so you're essentially changing it from 8% to 4% to 0% to 8% to 4% to 0. I guess it's 16% technically. So at the most you can reflect 16%, and just by changing how thick the glass is, you can turn it to 0. And saying all of this is the same thing, I would say, was ridiculous. I mean, saying the internal reflections are the same as why a prism separates the light is, you know, it's not all the same phenomenon. It's not all the same cause and effect mechanisms. Anyway, and they're all really simple repeating patterns, which indicates that atoms are doing something mechanically simple. That they are like a square, you know, and have sides. And so, yeah, oh, it's on the pointy part, now it's on the flat part. Now it's on the pointy part, now it's on the flat part. You know, just the simple fact of the idea of charge, you know, and the idea that all you're doing is you're taking the electrons, you know, around the outside, and you have the proton, and all you're saying is, well, if I move it a little tiny bit this way, all of a sudden now the proton is really visible from this side, and it's really invisible from this side. You know, I've changed it substantially in terms of what's viewable just by making this subtle little cause change. And that's the effect. So I can, you know, just by moving the electrons back and forth, you know, I can create all kinds of signals in the universe. And this signal on this side will be exactly the opposite of that signal on the other side. I mean, those are little hard pieces of evidence that indicate that it's not about this quantum crap. It's not about this everything's vibrating nonsense. Whatever. Wave packets. Wrong theory. Okay, well, anyway, I'm just saying I've given you more than good reason to doubt their wooey explanation and accept that it could be extremely mechanical, extremely simple. And that's all I want you to concede, is I've given you good reason to doubt the conventional woo bullshit. I've made a pretty good case in court that the client is innocent, and all you have to say is which side am I going to jump on? If I'm going to give some side the benefit of the doubt, which side should I give it to? The one that's obviously a religion, okay, and the one that's obviously the evolution theory. Who should I give the benefit of the doubt to? I think the answer is obvious. So anyway, enough. Hopefully it recorded. Yes, it did. Alright, so till the next time and such. This has been another DraftScience video presentation. You probably already know that. So I probably don't need that extra little bit. It's just a way of doing the transition from being here making a video to not being here making videos. It's good to have a transition. You know, just saying goodbye, well, it's kind of short. It just doesn't feel right. So it's just a human indulgence. Just indulge my human sensibilities, and I just need you know, graceful landing. So I just screwed up the graceful landing, but anyway. Yeah. So now I'm just doing the rambling, bouncing on the runway thing. But anyway, it doesn't really matter. So I'll just leave. So, till the next time, and such. There, that's good enough. The end.